Hello everyone. In this lecture, we will look into initially electromagnetic methods. We had already had a look into electrical resistivity methods, induced polarization method as well as cell potential method. This is one another method in which we are going to also measure the electrical resistivity or conductance of the subsurface. This method is known as electromagnetic methods. Electromagnetic methods make use of electrical field. Electromagnetic methods are also popularly known as EM methods. Here we make use of either the electric field or changing magnetic field mainly to excite the subsurface. Right? That means we have a transmitter coil as indicated here. Using this transmitter coil or loop, we excite the ground. Excitation happens both beneath the surface as well as above the surface. This ground current actually follows two fundamental principles of electromagnetic induction. First is the Faraday's law of electromagnetic induction, which estimates how the magnetic field interacts with the electric current and also produces electromotive force. And secondly, it also relates to Ampere's law, which states that currents generates magnetic field. Right? So, electromagnetic methods depend on these two laws, that is, one is Faraday's, number two is Ampere's law. Right? According to this method, together these two laws, what it does is they create an electromagnetic phenomena that leads to varying magnetic field, which in turn will result into varying electrical field. Right. This electrical field in turn lead to development of a secondary magnetic field. So, when an electrical current is induced into the ground, as we can see here, there is a loop through which we are going to induce electrical current into the ground. When the ground is a conductor, most likely it will be a conductor. A varying magnetic field is generated due to the induced current. Right? What it does is the current in turn leads to development of what is known as induced eddy currents. Right? The transmitter coil's current passes into the earth and in turn it produces what is known as eddy currents. Right? And the eddy current developed actually varies that depend on the subsurface. The amount of eddy current that gets developed below the surface due to the transmission of a field created by us depend on the subsurface conditions, and the secondary magnetic field that is going to be produced due to the applied current gives information about the electrical conductance of the subsurface. Thus, the major aim of electromagnetic methods is to get this information from the measured data and translate it to electrical conductivity or electrical resistivity images of the subsurface. So, this is the principle of electromagnetic method. It depends on these two laws, where in principle what we are going to do is we are going to have a transmitter coil through which we will pass the current. This in turn will excite the subsurface. By excitation, the subsurface beneath the surface, when it is a conductor, most likely the subsurface of the ground is a conductor which produces eddy currents, right. These eddy currents are also measured by a receiver loop, right. We will have a receiver loop. The way in which we arrange the transmitter loop and receiver loop can be done in several ways. That means this can be a transmitter loop, receiver loop can be put inside, or there are also other ways. You can also overlap, like this is receiver, this is transmitter, right. And the receiver loop gets the signal using which we can either measure the conductivity or the conductance of the subsurface. That is what we measure in electromagnetic methods. This can be done in two ways, right. So, what happens beneath the surface is clearly understood from this animation, where there is a coil, right. That is what we kept at the surface, which is the transmitter coil, right. Through the transmitter coil, we apply some current, which in turn develops some eddy currents within the surface, as indicated by this secondary field indicated by green color, that is sensed by a receiver coil, right. So, receiver coil measures the current that got developed below the surface, but measurement can be done in two ways. The first method is known as frequency domain electromagnetic survey. Here we measure the response of the subsurface at different frequencies of the applied current, right. That means we measure the response at several frequencies to obtain information about the conductivity of the subsurface, right. Or we may get the information only at one frequency, but usually in order to obtain differences in the conductivity with respect to depth, we apply current in different frequencies in the transmitter coil, right. And the problem in this method is a very small secondary field is measured. That means we apply large amount of current, that is the primary field, which in turn develops secondary field, which is measured by us, but this measurement is made in the presence of a large primary field, right. So, this leads to some decrease in the accuracy of the measurement. Is it clear? That means here you can see intermittently in the animation, you can see intermittently the work is done, but in frequency domain the current will be continuously applied, we will be receiving the signals. So, the receiving of signals is made in the presence of a larger primary field which we are continuously generating. So, this leads to some decrease in the accuracy. To overcome this, the next method, that is number 2, is known as time domain electromagnetic methods. This method overcome the issue which just now we had seen under this by using a primary field which is not continuous. Okay, that means the primary field, the application of current is done intermittently, right. So, the primary field is not continuous, but consists of series of pulses separated by periods, right. That means you apply the current and stop the application of current. The receiver coil will be activated when we have stopped the application of current. That means the transmission will be stopped and the subsurface of the earth remains energized for some time, right. During that time, the reception will be made. So, time domain electromagnetic survey achieve the same results of measuring the electrical response, right, but when we stop the application of the current. So, what we do is the response is measured to a pulsed wave at several time intervals after transmission. We transmit, receive, then transmit, receive, transmit, receive. So, this is what is known as time domain electromagnetic method. So, here the secondary magnetic field or secondary field induced by the primary field only is measured during the time interval when the primary field is absent. Okay. So, this is the difference between both the methods. In the first method, in frequency, the current is applied in different frequencies. Simultaneously, the receiver coil receives the electrical conductivity or the current that is produced. In the second method, the subsurface is energized or excited by application of current into the transmitter coil, and the transmission is switched off. The subsurface remains energized or excited for some time, during which we make the measurement. Okay. So, primary field is switched off, the secondary field generated is measured. Then again primary field is switched on, secondary field is measured. So, this is what is known as time domain electromagnetic methods. In both the ways, surveys are being carried out. Today, depending upon the requirement, we either use frequency domain or time domain. So, time domain is considered to be little more advantageous because of this issue, right. The issue is, in the frequency domain, we are measuring the small secondary field in the presence of the primary field. So, due to which there can be some marginal decrease in the accuracy that is overcome by the second method. Now, let us have a look into a much more sophisticated way of also simultaneously measuring both the signals which we have transmitted on the go. That means, the transmitter coil transmits the signal, the effect of that is picked up by the receiver coil, all done in few seconds, right. Within a second, several measurements are taken. This is known as towed time domain electromagnetic method, in which there can be a all-terrain vehicle in the front, which is attached to a transmitter coil. Behind that is the receiver coil. Sometimes the transmitter coil is very close to the all-terrain vehicle. So, both are towed and the vehicle keeps moving continuously. We make the measurement of the electromagnetic signal. Right here, you can see a small animation wherein, sorry. So, here you can see the all-terrain vehicle is moving with a transmitter coil behind that, right. I am showing this is the transmitter coil, this is the receiver coil. So, we can quickly complete the survey in the field. So, we had used this recently, couple of years ago, in the campus. This is the playground of Anna University. Right. Now, let us look into a ground based survey, right, which we had carried out very recently in our campus, thanks to the scientists who had carried out this investigation. So, what we did is, we kept a transmitter coil of about 20 meter by 20 meter, and we had a receiver coil of more or less the same dimension with a overlap, something like this. This is transmitter, this is receiver. So, different configurations can be made use of, and the differences between transmitted and received electromagnetic field is made use to understand about the presence of conducting body, and based on this we can arrive at the pseudo section, right. That means, we can try to get the pseudo section. The principle is inverse modeling. That means, we have got the results right, of the raw resistivity or conductivity data, and by inverse modeling, the model will assume a typical subsurface conditions. Using that, we can arrive at a pseudo section of conductivity. So, this section shows the pseudo subsurface variation in the conductivity. Here it is just inverse of that. Here it shows the depth wise variation in the resistivity of the formation below the surface, right. Here, due to some local noise, we could not get information up to about 10-12 meters. Up to 40 to 50 meters, we could carry out the survey with this arrangement, right. And the study indicated we are meeting the massive rock within a depth of about 15 meters, and beneath that rock is massive continuously. We also, the method indicates the presence of a fractured zone at a depth of about 50 to 60 meters. This study we carried out recently. We have also requested, he will also be giving you a lecture on this particular method with greater details, right. And similarly, the same technology can also be done from the aircraft. So, we have seen a small video indicating how we are towing both the receiver and the transmitter, right. The same method can also be adopted, which is known as airborne time domain electromagnetic method, in which a large transmitter loop, very large transmitter loop, which is of hexagonal frame, each of it is about 11 meters, then you can imagine. So, very large transmitter coil is lifted with the help of an helicopter, and a receiver is kept somewhere here, which is about 2 meter above the frame, right. 2 meter above the transmitter frame, receiver is kept, and also we have associated instruments mainly to measure whether there is any tilt in the frame during flying, right. So, that means we have two lasers are placed on the frame to measure the distance of the frame from the ground surface. Usually, we cannot carry it to greater altitude. At low altitude flying is necessary, about 200 to 300 meters above the ground, this frame will be taken, right. And in order to precisely measure the elevation of the frame from the ground surface, there are some tools used, and also we have a inclinometer which tries to measure whether there is any tilt in the frame, right, whether the frame is tilting this way or that way, right. Because when you fly, it is difficult, right, the frame will obviously may get slightly tilted considering the speed at which the helicopter is moving, and also due to prevailing wind condition, which also has to be measured by us, so that if there is any flaw in the data which we have collected, we can check whether it is because of tilting, right. And there is a in-house generator, right, which supplies power to the transmitting coil, right. This generator is also fixed between the frame and the helicopter, right. So, this is how very rapidly very large area can be surveyed using electromagnetic method. Let us look into some results. So, here is the result which I could get from this website on the subsurface conditions below this region, right. And similarly, in India, Central Groundwater Board, in association with the National Geophysical Research Institute, has carried out under the National Aquifer Mapping Project, carried out such an investigation in 5 different sites. In India, what we see is a site in Kadalur, which is located here. This is the site. This is the Bay of Bengal. right. This site is about 200 kilometers south of Chennai, right, wherein the same SkyTEM, right, method was performed, that is heliborne time domain electromagnetic survey was carried out, right. This area encompasses the sandstone sedimentary formation, wherein we have the India's large coal mine, which is in NLC coal mines are also located, that is the Neyveli region. So, the advantage of this method is, as you can see here, by flying we are able to understand at least up to 250 to 300 meters, right, depending upon the constraints. So, here information could be obtained at some locations even up to 300 meters below the surface of the earth, right. There can be some missing data also, right, but reasonably the survey indicated the subsurface conditions. Since flying has been done in this manner, all we have information at several profiles, we may be also able to interpolate between the profiles, right. So, such kind of a cross-sectional diagrams also are shown here, right. And there will be another lecture on this particular aspect by Dr. Senthil Kumar from Central Groundwater Board, who carried out this survey. Also by another friend of mine, Dr. Subhash Chandra from National Geophysical Research Institute. He will also be giving you an expert lecture on aerial or air-based electromagnetic